Pure forms of matter have all sorts of different properties. They have boiling points, they have melting points, some are flammable, some aren't. And we can divide them up into either physical or chemical properties. You hear these terms used a lot. So we're going to understand the difference between a physical and a chemical property, and we'll find examples of each. This is Screencast 3.4. Okay, here's a whole bunch of properties, and we'll take a look at some that are chemical, some that are physical, then think about it and figure out the difference between a chemical and a physical property. Chemical properties are kind of few and far between. They could include the reactivity of a substance, for example, mixing baking soda with vinegar. They could include the flammability of that substance. Most aqueous substances, I suppose all, are non-flammable. And we could have a various oxidation tendency for each substance, like the tendency of iron nails to rust. Okay, those are chemical properties. Physical properties include things like, guess what each one is? Melting point, density, magnetism. Most substances are not magnetic. Smushability, but let's use the scientific term malleability. Stretchability, but let's use the sciencey term ductility, the stretchability. Not the elasticity, but the just pulling out, say, of a metal. It doesn't bounce back. The color, the boiling point, the shininess or crystallinity of the substance, the tendency of the substance. A few substances, those that are transparent or translucent, to break up light into its component wavelengths. That's known as its refractive index. Or the just brilliant, not quite shininess, let's call this luster. Maybe slightly different from crystallinity, isn't it? And what's the difference between these two properties? Notice that these things are always getting messed up, destroyed. A chemical property involves a chemical reaction. Some new substances are formed. Carbon dioxide, water, carbon dioxide again. Same here. Physical properties involve the substance not being harmed, if you will. There's no chemical reaction. It's the same substance all along. Beware of phase changes. When water boils, it's still water. It's just either liquid water or steam. That's a physical change, not a chemical change. This is Screencast 3.4.